Hi guys, in this video we're looking at hyperbolas, and hyperbolas are very different to, I guess, your parabolas and exponential graphs. It comes in the form of y equals a over x. I think your textbook says k over x, and so if you replace that value of k or a in this case, it'll do the same thing. I just want you to see again in this particular case what happens to the graph when we manipulate different values, and helping you knowing what to expect and how to sketch the graphs, I guess, moving forward. So notice that the value of a is now divided by x, okay? And let's have a look at just an example. Y equals 1 over x. We've got this hyperbola, and I guess it looks like two graphs, one going that direction and the other one going this direction. And it never quite hits zero. Okay, it tapers towards zero, it never does that. So when you think about it, no matter, so 1 is equal 1 divided by 1, 1 divided by 2, 1 divided by 3, you could have that value go up and down. But when you try to divide a number by 0, so if x equals 0, you can't divide by 0, it's undefined. So let's say if we add this slider here, you'll see that it flips and it will invert going different directions, but it will never hit 0 if we made this really slow. So we'll go through a couple of these, but we're going to, I guess, make these comparisons to 1 over x. Okay, so let's say, let's move some of these down to the bottom. I want to talk about them a little bit later. Okay, so if we have a negative 1 over x, okay, so if this whole fraction is negative, we'll find that the graph is reflected, okay, and you'll see that the blue lines here are the opposite sides to opposite diagonals to your red ones, okay. So that's the first thing. The second thing is we're adding a constant. So you've noticed with some other ones that, well, what happens if we add a constant, a c value, that graph is going to shift up or shift down. Let's see what happens. So yes, so 1 over x plus 2 shifts the graph up 2 units, okay? And remember from the previous video on exponentials that the axis where it tapers towards but never reaches is your asymptote. So we have a horizontal asymptote of y equals 2, and that's your constant of 2. Okay, so if we have negative 2, it shifts the graph down 2 units, and the horizontal asymptote is going to be y equals negative 2. It tapers towards negative 2 but never reaches it. Okay, what happens if we decide to change the value of a? So we're increasing the value of a. Let's make that comparison. You'll see that it is not as skinny as your first one. So we might, so if we, I know the graphs is a little bit similar in color, but we'll make do with that. So you'll see y equals 1 over x is a very skinny one, tapers towards 0. Both of them does, but the 3, when you increase the value of a, it actually tapers it dilates. It actually makes your graph, your hyperbola, wider or fatter, however you want to describe it. Okay, so the larger the value of a, the fatter, the bigger the dilation of your graph or your hyperbola. It's a lot wider and it doesn't taper as quickly. And if we make this value of a more, we bring it 5, 6, 7, 8, you'll see that the dilation is making it wider even more so. So let's bring that back down to 3 here. So then we have another graph where, well, what happens if we have a coefficient of x down at the bottom? So we'll have 1 over 3x, and you'll see that, well, it's like the third, okay? So we're making it even smaller, it's making it skinnier, okay? So it's less than 1, it's going to make it narrower, so we can change this value to a 4, to a 5, to a 6, to a 7, to a 8, and oops, we can make that to an 8, and you'll see that it gets very skinny compared to 1 over x. Okay, and then lastly, I guess I want you to see, well, what happens, we've got the plus 2 on the side. What happens if we got the plus 2 at the denominator of this fraction? So it's 1 over x plus 2. So let's have that comparison with 1 over x, and you'll see that 1 over x plus 2 shifts it horizontally. So a plus 2, which sounds really weird in your head, shifts the graph towards the left 2 units. Okay, so here's 1 over x, and here's the hyperbola of 1 over x plus 2. And so x plus 2 would actually shift it left 2 units, going from 1 and 2 to the left. And so this value here is actually your vertical asymptote, okay? So x equals minus 2. It is a plus 2, but you want to have the negative of that, all right? And so then if we think about this one here, the next one, 1 over x minus 2, it's going to shift the graph 2 units horizontally, but to the right, okay? So 2 units to the right, which means your vertical asymptote is going to be at x plus 2. It's going to be the negative of whatever that value is. Okay, a little bit confusing. You'll get a little bit familiar with it as you practice it a little bit more. And we'll kind of finish off with these 2 questions or equations, and so you can kind of predict what's going to happen. Okay, so in this case here, we've got y equals negative 1 over 5x minus 1. Okay, so the first thing is, because this fraction is negative, it's going to, the hyperbola is going to be flipped. Okay, the next thing is, because the 5 in front of the x is there, it's going to be a skinnier hyperbola. Okay, and the last thing that I can predict from this graph is that because the constant is minus 1, there's going to be a vertical translation down 1 unit. Okay, so let's have a look at that. Okay, so in the green, it has flipped the opposite direction. That's the negative. The 5 makes it a much skinnier parabola, not parabola, hyperbola. And you'll see that the negative 1 has shifted the graph down 1 unit, and you've got a horizontal asymptote at y equals negative 1. Okay, so let's have a look at this very last question. In this case, we've got y equals 2 over x minus 3 plus 2. The minus 3 at the bottom is going to cause the hyperbola to translate horizontally 2 units. Oh no, so not 2 units, 3 units to the right. Okay, so this is the only case where you need to think the opposite of what the polarity is right now. So it's a minus 3, but it shifts it to the right. The 2 above is going to make the hyperbola fatter or wider. It's going to dilate it. Okay, and then the last one is that the plus 2, there's a vertical translation, 2 units going up. Okay, so let's have a look at that compared to y equals 1 over x and see if we are right with our predictions. So it has, it's not flipped, remember, because the fraction is not negative, so it's the same direction. It has shifted 2 units upwards. Okay, so the So here's your horizontal asymptote here at y equals 2. So the original one is at y equals 0, so it shifted 1, 2 units up. It has also shifted 3 units to the right. Okay, so instead of x equals 0, it's going 1, 2, 3, and your vertical asymptote is going to be at x equals 3. And then the 2 has made it a lot wider compared to your 1 over x. Okay, so hopefully this video has helped you. Let me know if you have any questions. Otherwise, I'll see you in the next video.